Ever just like spin your wheels on a project and you suddenly realize you were fixing the same bug like 10 different places? Ugh, talk about frustrating.
It's the worst.
It's like, fool me once, shame on you. Fool me 10 times, maybe. Maybe it's time to rethink how I'm writing this code.
And that, my friend, is where the DRY principle comes in.
DRY, don't repeat yourself. We hear it all the time in software development. But today, let's really dive into why it's such a game changer. And this is going to be no matter what coding language that you happen to be using. We've got some fascinating research and real-world examples we've got lined up for you.
Yeah, we're gonna look at when it might actually make sense to repeat yourself. It's true. It's true. DRY is more of a guiding principle than some like ironclad law. But first, let's define it. When we talk about DRY code, what are we talking about? We're talking about ensuring that every piece of knowledge in your system has a single, unambiguous, authoritative representation.
Single, unambiguous, authoritative. It almost sounds like we're like laying down the law for our code base.
In a way we are. In a way we are. Think of it this way. Imagine you are working on a large project and a client's address is stored in 5 different places in the code. Someone makes a change to one instance of the address but not the others. Suddenly you've got a recipe for,
Chaos. Which address is correct? Which one should we use?
Exactly, and that's why having that single source of truth is so crucial. It streamlines everything, from maintenance to bug fixing. In our address example, imagine if we had used a dedicated function to retrieve and update the address instead of scattering it throughout the code. Any changes would only need to be made in that one spot, making it far less error-prone.
Okay, so maintainability is a huge plus, but I'm also seeing how this ties into readability. Instead of hunting down all these different instances of the same piece of information, you have a clear, centralized location.
Precisely. DRY code is inherently more organized, easier to follow, whether you're a developer new to the project or you're revisiting your own code after a few months. There's even research suggesting that code written with DRY principles is perceived as less complex, which can lead to faster comprehension and fewer cognitive burdens on developers.
That's a huge win for, I think, any developer who values their time and sanity. We talked about maintainability, readability. What about the impact of DRY on bugs? It seems like having that single source of truth would reduce errors.
It absolutely does, and there's a mountain of anecdotal evidence to support this. For instance, there's a case study a few years back about a company that was building a large-scale e-commerce platform. They had to rewrite a significant portion of their code base because it was riddled with inconsistencies and redundancies.
That sounds painful. What went wrong?
They had multiple teams working on different parts of the platform, and they weren't adhering to DRY principles. This led to duplicated logic, inconsistent data handling, and ultimately a platform that was incredibly fragile and prone to errors.
A classic case of what can happen when DRY goes out the window.
Precisely. The rewrite was a painful but necessary lesson in the importance of DRY for building scalable and maintainable software.
Scalability. You hit on another crucial benefit. It's one thing to build a small application that follows DRY, but when we're talking about systems that need to grow and evolve, DRY seems even more critical.
Absolutely. When you've got a solid foundation of DRY code, adding new features or extending existing ones becomes much smoother. You're not wading through a swamp of redundancy trying to figure out where to make changes. You have a clean, organized structure to build upon.
So DRY is kind of like that trusty toolbox you take on every project no matter what you're building. It helps you create a solid structure, keep things organized, and avoid those frustrating moments of deja vu when you realize you're fixing the same problem for the 10th time.
And just like any well-stocked toolbox, DRY has different compartments for different programming paradigms.
Okay, so let's crack open those compartments. How does this DRY principle actually play out in different programming styles? We're talking about things like object-oriented programming, functional programming, that kind of thing, right?
You got it. Let's start with object-oriented programming, or OOP for short. The beauty of OOP is it allows you to create these reusable blueprints for your code called classes. Instead of rewriting the same code for every instance of an object, you define it once in a class and then create objects from that class.
So if we think about like a real-world example, like a car factory, the class would be like the blueprint for a specific car model, and each car rolling off the assembly line would be an object.
Exactly, and DRY is baked into this concept of classes. Inheritance is another great example. Let's say you're building a system for a library, and you've got a class for book. Now you want to add audiobooks to your system. Instead of creating a whole new class from scratch, you can create a subclass audiobook that inherits all the properties of the book class, but adds attributes specific to audiobooks, like narration, audio format.
Ah, so we're extending the functionality without repeating all that basic code that makes a book a book. That's clever.
It's about working smarter, not harder. And this inheritance principle in OOP is a prime example of how DRY translates into elegant and efficient code.
OPUP sounds like it has DRY kind of woven into its very fabric. What about functional programming? That seems like a whole different beast.
It is different, but DRY is just as relevant. In functional programming, the focus is on breaking down problems into smaller self-contained functions. Think of it like having a set of specialized tools, each designed for a specific task.
Got it. So I've got my toolbox, I've got all my specialized tools. Where does repetition come into play, and how does functional programming address it?
Imagine you're working with a list of numbers, and you need to square each number in the list. You could write a loop that iterates through the list and squares each number individually. But with functional programming, you can use what's called a higher order function, like map.
I've heard of it's basically a function that applies another function to each element in a list, right?
Exactly. So instead of writing that squaring logic within the loop itself, you can define a separate square function and pass it to the map function. The map function will take care of applying your square function to each element in the list, eliminating the need for you to write that repetitive looping logic.
Okay, that's starting to click. So instead of having 10 little hammers in my toolbox, I have one super efficient hammer, map in this case, that can handle a variety of nailing tasks.
And that's just one example. Functional programming offers a wealth of higher-order functions like filter, reduce, and for each that help you abstract away these common patterns and avoid writing repetitive, what we call boilerplate code.
So we've got OOP with its classes and inheritance, and functional programming with its higher order functions, all serving the DRY god. What about modular programming? Where does that fit into this DRY landscape?
Modular programming is like having a well-organized library of code. Each module is like a book on a specific topic, containing functions and variables related to that topic.
Okay, I'm liking this analogy. So instead of rewriting the same functions and variables in different parts of my code base, I can encapsulate them in modules and reuse them whenever needed.
Exactly. Let's say you are building a web application and you need to validate user input in several different parts of your application. Instead of writing that same validation logic over and over again, you can create a module, we'll call it validation, that houses all your validation functions.
And then I can just import that validation module wherever I need it, access those pre-built validation functions.
Precisely. This modular approach not only keeps your code DRY, but also makes it easier to maintain and debug. If you need to update your validation logic, you only need to do it in one place, your validation module.
No.
And if you think about it, this modular approach, it reflects how we naturally organize information in the real world.
Right.
Like we have libraries for different subjects and sections within those libraries for specific topics and so on.
It's all about creating a system that makes sense, whether you're organizing books on a shelf or functions in a code base. So we've seen how DRY kind of manifests in OOP, functional programming, and modular programming. I'm curious, are there certain languages that really lend themselves to DRY principles?
Absolutely. Languages that, embrace those object-oriented and modular programming paradigms are often considered very DRY friendly. Languages like Java and Python come to mind. Java, with its strong emphasis on classes, inheritance, interfaces, naturally encourages, code reuse and reduces that redundancy.
And Python, with its clean syntax and extensive standard library, often feels like it's handing you the tools to write DRY code right out of the box.
Exactly. And let's not forget about functional programming languages like Haskell. While Haskell might not be as widely used as Java or Python, it takes DRY to a whole new level with its concept of immutability.
Immutability meaning once you create a piece of data in Haskell, you can't change it. That sounds like it could lead to some very predictable and, dare I say, DRY code.
Precisely. In Haskell, you're encouraged to think about transforming data rather than modifying it in place. This eliminates a whole class of bugs that can arise from those unintended side effects when data is mutable.
So it's not just about, writing less code. It's about writing code that is inherently safer and more reliable.
Exactly. And while languages like Java, Python, and Haskell might provide a more structured environment for DRY, even languages that aren't traditionally considered DRY friendly can benefit from its principles. It ultimately boils down to the developer's mindset and their commitment to writing clean, efficient code.
So DRY is more of a philosophy, a way of approaching code, than a set of rigid rules tied to specific languages.
Precisely. It's about being mindful of that repetition, and looking for those opportunities to abstract away common elements, regardless of your language or framework of choice.
This has been a fascinating exploration of DRY's virtues, but I think it's time we address the elephant in the room, or rather the acronym WEATY.
Ah, yes. Wet. Write everything twice. The antithesis of DRY.
Or as some like to call it, we enjoy typing, though I suspect it's often said with a groan. Tell me, what are the real-world implications of embracing a wet approach to coding?
Imagine you are tasked with building a simple calculator application. And instead of creating a single function to perform, let's say, addition, you write a separate block of code for every possible addition operation. 1 plus 1, 1 plus 2, 2 plus 1, so on and so forth.
That sounds excessive and incredibly inefficient.
Exactly, and that's weight in a nutshell. It might seem harmless for small, isolated tasks, but as your code base grows, we can turn into this tangled mess of redundancy, making it a nightmare to maintain, debug, and scale.
So going back to our calculator example, if we need to update the way addition works, we'd have to go through and change every single instance of that duplicated code. Whereas we had a single add function, we could make that change once, and it would just propagate throughout the application.
Precisely. And that's just one small example. In large-scale applications, WT can lead to massive code bloat, increased development time, and a higher likelihood of introducing bugs. It's like trying to navigate a labyrinth with endless dead ends and repeating corridors.
So while wheat is clearly problematic, even DRY, when taken to an extreme, can have downsides. I recall a time when I got a little too DRY happy, trying to abstract away every little piece of code, and I ended up with something that resembled a Rube Goldberg machine more than elegant software.
Ah, yes, the allure of premature abstraction. It's a trap many developers fall into. Remember, DRY is a guiding principle, not a rigid dogma.
It's about finding that sweet spot, that balance between being DRY and keeping things clear, concise, and maintainable.
Exactly. It's like that old saying, everything in moderation, even moderation itself. You have to use your best judgment as a developer to determine when DRY is the right tool for the job and when a little bit of repetition is actually the more pragmatic approach.
Speaking of judgment, are there any red flags that developers should be aware of? Situations where it might be tempting to go full DRY, even if it's not the most practical approach? I'm thinking of times when, like, code might look similar on the surface, but actually serves different purposes under the hood.
That's a great point. Just because two pieces of code look alike, it doesn't necessarily mean they have the same purpose or context. Forcing them together under the DRY banner could create more problems than it solves. Sometimes, a little bit of duplication, when done consciously and with clear justification, can actually enhance the clarity and maintainability of your code.
It's like, just because two recipes call for flour doesn't mean they're making the same thing. You've got to look beyond the surface to understand the intent.
Precisely. Blindly applying DRY without considering that context can lead to what we call accidental duplication. You might end up abstracting away code that seems similar, but actually has subtle differences, making it harder to understand and maintain in the long run.
So it's not just about eliminating all duplication, it's about eliminating harmful duplication.
Exactly. It's about making conscious decisions about what to abstract away and what to keep separate, even if it means repeating a few lines of code.
And those decisions, I imagine, can be influenced by a variety of factors, right? The size and complexity of the project, the team's coding style, even the long-term goals of the application. It's not always like a one-size-fits-all approach.
You hit the nail on the head. A deep understanding of the problem domain, the project's architecture, and even the team's dynamics can play a crucial role in finding that sweet spot between DRY and pragmatic code duplication.
This has been a fascinating deep dive into DRY. We've, gone beyond the surface level, exploring the nuances, the trade-offs, and even like the potential pitfalls of taking it too far. But before we wrap things up, I want to leave our listeners with something to kind of chew on. We've talked a lot about like the technical benefits of DRY, better maintainability, readability, reduced bugs. But I'm curious about the less tangible benefits. What about the impact of DRY on like a developer's mindset?
That's an interesting angle. I think DRY encourages a certain elegance in coding, a okuzir, as I might say in Russian.
Suitor of the arc. I like that. A striving for beauty in code.
Exactly. When you're mindful of DRY, you're constantly looking for ways to, like, express your intent more clearly, more concisely, with less clutter, less redundancy. It's like the difference between, a rambling paragraph and a well-crafted haiku. Both might convey the same basic idea, but the haiku does it with an economy of language that's both elegant and impactful.
So DRY is not just like a technical principle, it's an artistic one as well. It's about finding that perfect balance between form and function, creating code that is both efficient and expressive.
Beautifully said. And just like any artistic endeavor, mastering DRY takes practice, experimentation, and a willingness to constantly refine your craft.
To our listeners, as you continue your coding journey, remember DRY is more than just an acronym. It's a philosophy, a guiding star. But, not the only star in the sky. Sometimes a little calculated repetition done with purpose and clarity can be the key to unlocking even greater elegance and maintainability in your code. Keep those cognitive wheels turning and never stop exploring new ways to write cleaner, more efficient, and yes, even more beautiful code. This has been the deep dive. We hope you enjoyed this exploration of DRY. Until next time, happy coding.